Dylan, Florian, just checking that you can hear me.
Hey, James. Hi, everyone.
Yeah, hello.
Okay, perfect. Hey, everyone. I hope you're all well. Welcome to our Twitter space today, where we'll be discussing the current state of scaling solutions and rollups in particular, and where Mina sort of sits in this conversation. Happy to be joined by Dylan Cougler, who works with me at Mina Foundation, and Florian Kluge from O1 Labs, who spent a great deal of time working on ZK Fusion, a modular ZK rollup for Mina, and who is probably better placed than pretty much anyone to be talking about this topic as it relates to Mina. So thanks, guys, for joining today.
Thanks, James. Great to be here.
Yeah, so myself and Dylan put out a blog piece yesterday on the Mina website discussing this topic, and we're hoping to fill in some of the gaps that will inevitably accompany an article on sort of this deeper topic. We'll be looking to produce more blogs over the upcoming months in different areas so that people can better understand Mina's relevance to these narratives. And whenever possible, we'll look to accompany these blogs with a Twitter space with sort of relevant guests from the Mina ecosystem. Please ask any questions that you may have throughout the space in our Discord or as a reply on Twitter, and we'll try and address them at the end of the talk. So let's get into it. So guys, I feel pretty old because I still remember the days where we used to hear about sort of plasma, state channels, side chains, and these kind of things as being the primary scaling solutions. What has happened in your view in the landscape over the past few years to kind of get us to where we are right now, where there seems to be a strong consensus forming that a roll-up future is the main direction we're heading in? Dylan, what are your thoughts on that?
Yeah, it's a great question. Honestly, I'm excited to be able to chat about this. It's a pressing and exciting topic. So I think to start, it would be good to understand what a rollup actually is. So rollups are an off-chain scaling solution that executes transactions outside of the core layer one. So in a rollup, many transactions are batched off-chain and summarized into a single block that is then submitted to the layer one. By posting a single transaction consisting of a large number of off-chain transactions to the main network, rollups are able to increase the scalability and throughput of the underlying L1. Rollups are just one of several different scaling systems alongside, side chains, channels, plasma, as you mentioned, James. Basically, the design for a scaling system is to make faster and cheaper transactions. I will say rollups are probably the ideal scaling solution. They don't have their own consensus. Most of them don't have their own consensus model, and they leverage the security of the settlement layer. They're also able to add significant amounts of modularity to the base layer. While each of these scaling solutions you mentioned has their own considerations and trade-offs for throughput, cost, security, scalability, and many other different options, but it's really just become community consensus that rollups are ideal because they provide a secure, efficient way to scale without sacrificing decentralization of the L1.
Yeah, I'd be interested to sort of hear what you think as well, Florian, on this side. Like, why do you think we've got to this stage? Sort of what got you interested in rollups, and sort of why do you think the general sort of crypto ecosystem is kind of rallied around?
Yeah. So like you already mentioned, Dylan, there are a couple of sort of like other scaling solutions like side channels, plasma, state channels, whatever. But rollups for me especially, and pretty much only ZK rollups, are like something very sophisticated and like beautiful in how they are sort of like constructed. And they're not only beautiful in a sense, like, like they rely on awesome cryptography and math and awesome engineering, but they're also a real solution to scaling really inefficient blockchains, like, for example, Ethereum, where you have like to pay a lot of gas for a basic DEX swap, which, after some time gets very annoying. So what we do is we go to rollups, and they make the world a bit easier, especially on inefficient blockchains, right? So they not only sort of like decrease the fees that you have to pay, they also sort of like speed up everything and increase the overall user experience, which is a very, very important thing currently in the blockchain world, because, you know, if you
Yeah.
don't have a decent application, then users not
Yeah.
use it.
For sure. I mean, I think you mentioned the concept of a ZK rollup there, and I'm sure that most people that are tuned in are at least aware of the different kinds of rollups. But as we're on the subject, it's probably worth us sort of briefly visiting the optimistic versus ZK rollup debate. I think it seems to be one that tends to get people talking a lot. Can you guys sort of briefly go over the differences, and then kind of we can go on to maybe why we've seen a proliferation of activity on certain optimistic rollups, whereas ZK rollups have been slower to launch and to acquire TVL. So Dylan, what are your thoughts on
Yeah,
this?
I can start with your first point, defining what an optimistic and zero knowledge rollup actually are. So basically, they both types batch up transactions off chain into a single transaction that is then fed to the L1. The main difference between an optimistic and a zero knowledge rollup is how the state transition is verified on chain. In a ZK rollup, transactions are processed off chain and then verified on chain using zero knowledge proofs. As Florian mentioned, there's a beauty in kind of how ZK rollups produce a cryptographic guarantee. This is called a validity proof that verifies the state transition, which proves the correctness of the changes. This is in contrast to an optimistic rollup, which assumes that all transactions are valid, hence the name optimistic. In an optimistic rollup, all transactions are valid until challenged. Following the submission of an optimistic rollup batch on the base layer, a challenge period is initiated during which any individual can challenge the outcome of a rollup transaction by generating a fraud proof. Herein lies the biggest difference. While optimistic rollups rely on users and validators to raise a challenge, ZK rollups verify all state transition cryptographically. I think, there are many additional ways we can compare the two rollup types, and happy to jump into them as well.
Yeah, I mean, I think that it's, I always get concerned, like having been in crypto for a long time, that people, they tend to just see adoption as sort of tacit kind of tacit acceptance that something is inherently better than the other one. And what's interesting here is that Vitalik has spoken, I think, at length about how he believes that ZK rollups are going to be at least part of the end game, and that there is a sort of, he has an inherent preference for them over optimistic rollups. And yet people are sort of looking at the space at the moment and going, hey, why is all this TVL accumulating on Arbitrum and Optimism, and yet sort of the ZK rollups that are in production, in a production environment, that are on mainnet aren't getting there yet, or at least are close to mainnet. So why do you guys think that is? Dylan, you might want to go for it. I think that Florian may have dropped out.
Yeah, no problem. So it's true. I mean, if we look at some of the TVL for Arbitrum and Optimism versus, ZK Sync or Starknet, it kind of, it's a huge difference. But, I think ZK rollups lag behind because it's just a significantly more complex technology, and there is limited compatibility with Ethereum from a zero-knowledge Spark perspective. As the technology improves, we should start seeing developers leverage other chains like Mina as a zero-knowledge programmable layer. And, with that, we'll also, some ZK EVMs will start taking some market share away from the optimistic side. But, right now it's difficult to build on the ZK EVMs. Optimism, Arbitrum, they're fully EVM compatible. They're extremely easy. And a lot of projects are building there right now. So, we'll see some changes going forward, but it's just more complex, ZK.
Yeah, I mean, we'll definitely come onto sort of this Mina specific elements of rollups later on in the discussion. But Florian, I'm interested to sort of hear your thoughts here as to, you mentioned sort of ZK rollups being sort of like a better design as such. Like, what are your sort of, why do you think that, first of all? And secondly, why do you think it's taking so much longer for ZK rollups to get to mainnet and to sort of get adoption in the wider scheme right now?
Yeah, could you repeat the first question? My internet just dropped. So
Yeah, so the first question was with regards to what you said about ZK rollups being sort of a more, I guess, optimal design.
yeah, okay. So
yeah.
To briefly talk about that, if we look at previous scaling solutions like optimistic rollups or sidechains, they all had sort of like optimistic, as the name already indicates, security assumptions. So they sort of are easier to build. They're more, like easier to get off the ground, easier to get running, and hence they're also more popular. But they aren't sort of like as secure as rollups, because you have to sort of like wait for a challenging period on chain. You can't immediately withdraw your funds, and you never really know what's going to happen with your money. So they are not as secure as ZK rollups. And if you look at ZK rollups, they rely on mathematical proofs on cryptography to prove that you indeed executed a transaction, that you really received money. And so they just have sort of like more security assumptions, which is obviously a sort of like big thing. But yeah, because of those cryptographic proofs, they also took longer to get off the ground. People had to develop very sophisticated proof systems. People had to research all the math behind it, not only to make very basic transactions, but also to allow sort of like arbitrary computation like the CK-EVM, complex smart contracts and all that stuff. So they are like certainly more sophisticated, and hence they take longer to sort of like grow within the community. And another perspective is also the complexity of the technology behind it. So people, they might not directly understand how everything is working and why they should trust the cryptography. So there's always like a sort of like a understanding, a gap between users and then the people building it. So yeah,
Those are
Oh, that's super interesting.
so. I would like
Sorry.
sorry about that. I would like to kind of iterate and just expand a little bit on a couple of things that Florian just mentioned. Florian mentioned the challenge period. This kind of directly impacts it, and this directly is the reason why I think ZK rollups will eventually win out over optimistic rollups. Florian mentioned the challenge period. All fraud proofs for an optimistic rollup are accompanied by a 1 to 2 week challenge period, which impact the transaction finality, whereas ZK rollups can basically be executed as soon as a proof has been verified and the L1 consensus agrees. And the next point that Florian was mentioning was about kind of security. It's important to note that, optimistic rollups rely on crypto economics for security, but I wouldn't go so far to say that it's inferior to a more cryptographic zero-knowledge proof approach, but it is true that optimistic rollups do require at least one honest node. The odds of this are pretty high in the real world, but inherently ZK rollups have a more secure design.
Yeah, that makes a lot of sense. So I want to switch things up here as we don't have too much time, and I want to talk about Mina specifically. So, Florian, you're probably the preeminent expert when it comes to rollups on Mina. So, could you explain sort of how Mina's unique characteristics and features make it a strong fit for adopting a rollup strategy? And I'm particularly interested in anything you can say sort of about the benefits of recursion.
Yeah, so this is a very big topic, and I don't think we have enough time to explore the entire space. But just to start from the very beginning, Mina itself, if you think about that, is also a decentralized rollup. So what that means is you have a decentralized sequencers, nodes in the block, and the network generating blocks, and then we also prove execution of every single smart contract and use recursion to sort of like combine that into one thing. So Mina itself is already a rollup, but that's not the only thing that's awesome about Mina. There's something called ZK apps, and I think most people here are familiar with that. ZK apps are our smart contract layer. They allow us to execute smart contracts on Mina, but in a very specific way. Instead of sort of like having to deploy your code to the contract, and telling every single node in the and in the network to run your contract, your code. You do it off-chain and generate a proof of the correct execution, and then you only send the proof on-chain and verify it there. So this is a very interesting pattern that allows for all sorts of complex application, starting with, again, off-chain smart contracts, and then more sophisticated systems like rollups. Rollups can have many different forms. They can be sort of like general purpose. They can be app specific, or also called app chains. Then you can have rollups that do fund transfers or like other off-chain applications that rely on recursion. And because the sort of like the recursion layer is already baked into Mina, it's on the very sort of like foundation of the protocol, and we continue using recursion to grow the chain essentially recursively. This is a very powerful tool that also developers can use. And the good thing for Mina is that the verification on-chain is also efficient. And as opposed to other chains like Ethereum, you have to pay quite a lot of gas to get your proof verified. So it's efficient. It's sort of like directly built into, and it's easily accessible by using SnarkyJS. So it's like a sort of a dream for any rollup developers.
Yeah, I mean, like on that topic, can you speak a little more about sort of SnarkyJS and why that is sort of like why it is so easy to use for most developers out there?
Yeah. So there are a couple of famous CK libraries tooling. For example, there's Arcworks, which is a bit more low level. Then you have Circom, which you can use to write and then generate proofs for example, Ethereum. But with SnarkyJS, the sort of like the awesomeness about it is that you have, but first of all, it's written in sort of like a TypeScript JavaScript library, which means that you can just write your circuits using TypeScript JavaScript. You can sort of like use all existing tooling that is accessible within the sort of like broader JavaScript ecosystem. You can run it in the browser using Wasm. So you can directly generate a proof in the browser, but you can also use Node.js to generate proofs in a more server-like environment. You can use the entire ecosystem of different packages. You have test runners like Jest. You can simply import libraries and use them in SnarkyJS. So it's like a massive thing that you can do, and it's very easy to use. And under the hood, you can not only generate normal CK proofs, but you can also generate recursive ones. And you do that by simply sort of like calling a couple of functions in SnarkyJS, which feel like plain TypeScript, JavaScript, and that gives you the power to generate recursive proofs without any issues, essentially. So it's like very easy, very developer near. So it's like pretty cool.
Yeah, that's awesome. That's awesome. And I guess it wasn't all sort of roses when you were building, when you were sort of working on ZK Fusion. So what are sort of the inherent difficulties, or I guess the improvements required to make it easier to develop rollups on Mina going forward?
Yeah. So rollups are still something that are actively being developed and sort of like researched by teams. We are only now seeing the sort of like CK EVM wars where you have big projects sort of like going into the mainnet phase. So it's definitely a technology that is still actively being developed. And yeah, then just simply sort of like getting into the mindset, how to use CK, how to develop CK programs, how recursion works under the hood is something that even though it's easy to write, you have to understand how it works to write efficient programs. And yeah, so it's like a different way to write software, because you're not really like computing things. You only prove the computation, then you get a proof, and then you recurse that. So yeah, and then there are like certainly API changes that can make it overall more accessible, easier to use. So there's a couple of things. But I guess the biggest one is probably getting into the zero knowledge programmer mindset, understanding the concepts, understanding how you can leverage things, and understanding how you can optimize your application.
Yeah, I'm sure these things will develop over time for sure. And one thing I've always been curious about, Florian, I'm not sure if you can help on this, but like, how do you see sort of cross rollup communications becoming a reality on Mina? So what are the impediments to getting there?
Yeah. So maybe to take a step back, rollups are inherently sort of their own islands. There you have like a couple of rollups here and there, but they can't really communicate with each other. You would have to withdraw funds back to the layer one, then go over to the second rollup, deposit them again. It's just very annoying. So a possible solution for that could be to use a interoperability network, a composability network. And the good thing is with Pickles, which is the recursion protocol used in Mina, you can verify proofs arbitrarily. So that means that you can have a proof from rollup A or application A and verify it in a completely different application, merge it together with a completely different proof, and then you get like something that's completely new. So the functionality already exists. However, I think in order to have a flourishing interoperability network on Mina, someone has to come up with a standard, like an IBC for CK. I think CK IBC is also a hot topic at the moment. So we need a interoperability interface that developers can use and leverage to build their applications. But yeah, I'm like very excited for that idea. That's going to unlock a lot of interesting use cases.
Yeah, that's awesome. That's awesome. And actually, I wanted to pick up on one earlier thing that you were talking about, which was you mentioned app-specific rollups and general-purpose rollups. I think for those who sort of don't understand the difference and sort of what that involves, can you elaborate on that a little?
Yeah. So application-specific rollups only serve one purpose, essentially. You have an application that is at the moment maybe living on chain, but you want to sort of like elevate that application to use recursion off chain to improve the performance of your application. And then there are more general purpose, also like sort of like I guess generalized rollups that you can use to deploy your application on top of. It's like an existing network, and you have a couple of applications living on that network. For example, the entire sort of like CK EVM thing is more generalized. You have multiple applications living on that network, as opposed to having one rollup network per application, which sort of like builds an application-specific rollup. So there's like all sorts of things that you can do with rollups, but I think those are probably the two big categories that I consider.
Okay, that's awesome. That's great. And I kind of want to switch up here. We only have a few minutes left. I want to talk about sort of layer 2 governance, if you guys don't mind. I think that sort of many people are willing to be pretty reductionist when describing DAOs, but I think on the other side, there's like this real hope that these sort of tech-powered social organizations can potentially grow into these entities that will eventually rival traditional companies and government institutions. I'm sure a lot of people here have followed the recent governance issues at Arbitrum, where what people were led to believe was a vote on the award of tokens to the Arbitrum Foundation was actually a ratification. Yeah, I guess my view on this is that if these systems are ever able really to scale or to replace or supplement centralized corporations, that the industry needs to figure out sort of what they're actually good for. Dylan, I'd love to get your thoughts on governance generally and as it relates to layer 2s and rollup chains.
Yeah, it's such an important question, especially in light of the recent situation with Arbitrum. So governance for a rollup can probably be handled in many different ways. The most common approach would be using on-chain mechanisms such as token-based voting systems or off-chain mechanisms such as community forums and decision-making processes. But most importantly, transparent communication is kind of the most important thing, and that's what failed Arbitrum last week. This could involve setting up a governance forum, chat channel where community members can discuss freely. There has to also be very clear guidelines and criteria for decision making and a very transparent and fair process for voting. All community members should have a fair opportunity to participate in a decision-making process, and their votes should be weighted appropriately. Overall, the effective governance for a rollup would require a strong commitment to transparency, community involvement, decision-making, and by involving the community in the governance process, we can ensure that all the voices are heard and that rollup projects can create a good sense of ownership and engagement, which only helps the long-term success and sustainability of the network. Excited to see what kind of projects are being built in a more decentralized rollup environment for Mina, and how we can kind of approach governance from that angle too.
Yeah, for sure. I think this is kind of ongoing, even for sort of layer one chains as it is. But yeah, it's going to be interesting to see how this sort of proliferates over the next 6, 12, 24 months, etc. Okay, so I think we can probably switch to a Q&A. We have had a few questions in Discord. I'll pick out one or two of them, and then we can potentially get a couple of people live to ask questions. So I'll start with a couple from the Discord channel. So one of the questions is, can you speak to how many existing scaling solutions are more centralized and why this isn't the case on Mina? Florian, can you help on that?
Yeah. So decentralizing rollups is a very important topic, and that's also something that's very actively being worked on at the moment. The idea, sort of like the original idea of a rollup, is to have one, or at least a CK rollup, is to have one centralized sequencer that takes all the transactions, orders them, and proves the correctness of them, and then sends the proof to the settlement layer. That approach is secure in the sense that the centralized sequencer cannot manipulate any transactions, because then they wouldn't be able to generate a valid proof. But there is still an incentive in trying to decentralize the entire system. And that's, again, an active topic being researched at the moment, with like other projects working on rollups, mainly in the Ethereum ecosystem. But I think a very interesting point, again, is that Mina itself is a decentralized rollup. It has a decentralized networks of provers, of block producers, and I think we can sort of like learn from that design and then also apply that on layer 2s, especially with Mina allowing for arbitrary recursion and interoperability. We could also, in theory, build a network of sequencers that are decentralized, that generate proofs for all sorts of rollups, sort of like an interoperability sequencer network.
Yeah, that's super interesting. So yeah, I mean, I guess that's something that a lot of chains sort of experiencing at the moment, is sort of the issue of decentralization when it comes to their rollups. On the sort of scalability side of things, I think the people, this harks back to sort of the alternative layer 1 days. People have a sort of hang up when it comes to TPS, right? So transactions per second. So one of the questions we have from Mark here is, will ZK rollups increase Mina's transactions per second?
Yeah. So I guess short answer is yes. But it's important to mention that rollups don't increase the TPS of the set of the layer 1, but they do increase the overall sort of like TPS that are happening off chain. And they also improve the user experience. They do lower the finality, so people don't have to wait an hour for their transaction to be finalized, to be sure that there is no reorg going to happen. So they improve both speed as well as finality and user experience. So that's definitely going to happen.
I'll add to that. Thank you. I'll add to that. So, blockchain benchmarks are more nuanced than just TPS today, especially for Mina. If ZK apps transactions can verify one proof each, these proofs can each contain like an infinite a ton of different internal individual transactions for that ZK app. It is a complicated subject, but if we look at Mina as a recursive platform for a new style of rollups, the reality of the TPS is very different.
Yeah, just want to briefly add to that. I completely agree. Sort of like benchmarking blockchains by using the metric of TPS is something I don't like to use because I think it doesn't really say anything. And again, we can use recursion, only one recursive proof that could prove 1 million transactions, right? But on-chain, we would still have one TPS, one sort of like one proof being verified, but that one proof includes 1 million sort of like mutations of the network, which is very powerful. There's also, for anyone interested, there's a website out there who benchmarks different blockchains and their TPS, including popular scaling solutions like zkSync. And when you look at their TPS benchmarks, you will see that they usually don't hit a lot of TPS because they're like not on demand, and TPS is sort of like a very hard thing to benchmark. But yeah.
Awesome, guys. Thanks for that. We have one more question that is coming from Orsa. I think you should have been made a speaker, so feel free to speak up.
Hello, thanks. Great conversation so far. I wanted to ask about sort of the data availability problem as it relates to Mina. So for rollups, like the data all needs to be posted somewhere, hopefully back to L1, so you can like reconstruct the state. And Ethereum's going through a bunch of changes with like Dink sharding and EIP 4844 to like try and make more room for basically all the rollups. So could you talk about how that would work on Mina?
Yeah.
So
you are correct in the sense that you have to sort of like make the data public, that, and so in order that people can take the data, and in case of something going wrong, they can still withdraw their funds. Unfortunately, on Mina, we can't store a lot of data. It's a very tiny chain, so we can only store commitments. So what we do is we can rely on different blockchains and systems to store the data for us. I guess technically that wouldn't make the rollups a rollup, but more like a Validium. But I think they're probably still similar in their sort of like terms. I know that there are a couple of projects in the community working on data storage solutions. I think there are 2 who won the CK Ignite proposals just very recently, so you can take a look at them. And I also know that there are other teams exploring that using a sort of like different chain for data availability. And so yeah, like there's a lot of research going on at the moment.
Awesome. Yeah, we have one more question. Thanks for that question, Porter. So one more question is, what is the difference between a ZK rollup and a ZK rollup? I saw a ZK Ignite project that is the latter.
Yeah, so I'll take this one. So speaking about the ZK Ignite project, it's a company called Anomics. Anomics is, we have a couple of projects right now being funded through the Mina accelerator, ZK Ignite. Anomics, to give context, is a ZK rollup L2, and there's another one that got funded called Nord, which they described as a scalable, modular, interoperable ZK rollup. A ZK rollup just refers to the fact that you are taking a zero-knowledge proof of a zero-knowledge proof, basically proving that the proof is correct. It's a way to kind of create a little bit more anonymity, obfuscation, and as it relates to the ZK Ignite project that you were talking about, Anomics, they're making more of a private on-chain operation. So that's where the ZK kind of concept comes in. But it's just another phrasing for recursive snarks, which is Mina in a nutshell.
Yeah, you gotta love all these ZKs and all these different letters that we have to learn.
We need better naming.
All right, guys, I think that's, yeah. I think that's all the time we've got for the Q&A. Thanks, guys, for joining. So if you guys want to hear more about this, please read the blog for a written overview of the Rollup landscape. Also, check out Mina's public roadmap that was updated this week to dive deeper into our Rollup strategy and our vision. Dylan and I will be back soon for another space, so keep an eye out on the Mina socials, and we're hoping to write some more blogs in the coming months. Thanks everyone for tuning in, and thanks Dylan and Florian for your time. It was great catching up.
Thanks so much for having me.
Thank you, yeah.